Hi, I'm Dhruti, and I've taken the topic of first come, first serve and presented to Sumana ma'am. Next slide. Moving on to the next slide, content. So, contents are introduction, experimental setup, implementation steps, observation, and comparative evaluation. So, in introduction, we can see system operation or OS scheduling, in which OS scheduling determines the order in which processes access the CPU, and its main goal is to improve CPU utilization, minimize waiting or turn around time, and ensure fairness. And in first come first serve scheduling overview, first come first serve is the simplest non-preemptive scheduling algorithm, and also it is very basic. So processes are executed in the order they arrive in the ready queue, and in objective of this assignment is to design the implementation and first come first serve scheduling simulator using C to evaluate its performance using three different data sets, and to compare FCFS with SJF and SRTF, and to analyze suitability for real-time systems. And moving on to the next slide, experimental setup. And in experimental setup, the programming languages we have used is chosen C. We have used C program because for the chosen for a speed, low level control, and relevance to operating system concepts, means OS concepts. And the tools we have used is IDE or editor like VS Code, or compiler, GCC, and execution environment is Windows or Linux terminal, and in operational tools, online GDB or program is for quick testing, and the process and bus time P10 and bus time 7, P2 1 for arrival time 1, and for bus time 3, and for P3 arrival time 1 and bus time is 1, and for P4 arrival time is 2 and bus time is 2, and also for P5 arrival time is 4 and bus time is 5. So dataset description. In dataset description, three datasets were used to evaluate FCFS behavior, like dataset A, dataset B, dataset C. In dataset A, it is staggered arrivals, and in dataset B, it is all arrival time at 0, and in dataset C, mixed dynamic arrivals, means convoy effect. Moving on to the next slide, implementation steps. And in implementation steps, first point is define data structure. What is data structure? So create a process struct with fields like PID, arrival, burst, start, completion, waiting, and turn around time. And in second point, dataset input or dataset selection. Let the user choose manual input or one of three sample data sets like A, B, C, which I told in the previous slide. And second point is for manual input. Read N and then arrival and burst for each processes. Sort processor, sort the process array by arriving time, like break ties by PID to keep stable order. Next, fourth point, simulate FCFS, which means initialize time is equals to 0, means arrival time is equals to 0. So for each processes in a sorted order, start is equals to max of time comma arrival. For completion formula, these are the kind of formulas. And completion is equals to start plus burst, and waiting is equals to start minus arrival, and turnaround is equals to completion minus arrival, and update time is equals to, which means completion time. So next is collect matrices, which means for each processor show the computer start, completion, waiting, turnaround. So like then compute average waiting and average turnaround time, and in the output print a need per process table with all fields, and print average waiting and average turnaround times, and then print a simple textual Gantt chart showing start time and processes blocks. Moving on to the next slide, flowchart. So in flowchart, it is a kind of procedure for solving the algorithm, which is algorithm first come first serve. It is a kind of process. Let me explain. So first we will start this, and then as I told in the implementation step, it is then asked for the input or load data, and then sort by arrival times, means arrival times. Like then we check the arrival times, which is small and that is and all. And then for each process, start is equals to, it is a formula which I told in a previous slide. Start is equals to max of time, comma arrival, and completion is equals to start plus burst. Waiting is equals to start minus arrival. Turnaround is equals to completion. Time minus arrival time. Time is equals to completion. Then print the results and then end. Which this process, which follows, I mean, this process follows the follows in code while executing the code follows this kind of procedure. And then in code, it is the code for the FCFS, and here is the output for the code. It asks to enter the number of processor, like I have entered the four numbers, and for it asks for P1 arrival and then P1 burst, and P2 arrival and P2 burst, P3 arrival and P3 burst, and then P4 arrival time and P4 burst time, which I'll be executing in the last of this presentation. And I will execute and I'll show the program. And then moving on to the next slide, annotated Gantt chart. Here is the annotated Gantt chart, like time and all, which is the solved Gantt chart for the given FCFS algorithm, and then observations of the FCFS, which means first come first serve. So waiting time. Waiting time increases when long process arrive before short ones, like convey effect in dataset C. In dataset C, it follows like that. And then FCFS produces the highest waiting times, while SRTF gives the lowest due to preemption. Means preemption. So then turnaround time. Turnaround time follows the same trend as waiting time, since it includes both waiting and burst duration. And then SJF and SRTF reduce turnaround time significantly compared to FCFS. And then response time. In response time in FCFS and SJF, which is non-primitive, so response time is equals to waiting time because the process starts only once. And in SRTF, response time is lower because short processes are executed sooner, sometimes immediately after arrival. Because short processes like take very smaller time, and long processes take very larger time. And fourth point, number of context switches, which means in FCFS, very few context switches because it is non-primitive, and in SJF also minimal context switches, which is because it is non-primitive, and also SRTF highest number of context switches due to frequent preemption when short processes arrive. And then moving on to the next slide, comparative evaluation. So is a table for the comparative evaluation, which we have taken the taken three kinds of algorithm, which is FCFS, SJF, and SRTF. Like considering the average waiting time, average turnaround time, and which means average TAT, and then context switches and remarks. Remarks in the sense like how it works and all. Here is the table for that. And then moving on to the conclusion step. Okay, FCFS is simple but performs poorly when long jobs arrive first, resulting in high waiting and turnaround times. And in SJF improves performance, while SRTF gives the best result overall due to preemption. Therefore, FCFS is not suitable for real time or time critical system. And now I'll be executing the code. Yeah. So here is the code for this, which I've typed in the online C compiler. Let's run the program. So it is asking to enter the number of processes. So let me enter the number of process is 4. And after entering it it asks me to enter the value for P1 arrival. So which I'll be entering arrival time like maybe 0, and then burst time it asks for P1 burst time, I'll be giving 2, and then P2 arrival, I'll give 1, and P2 burst I'll give 4, and P3 arrival I'll give 2, and P3 burst I'll give 6, and P4 arrival I'll give 3, and P4 burst I'll give 8. So here is the after entering the processes and all, it gave me the Gantt, it gave me the soft algorithm. Here it is a process, and it is arrival time, burst time, start, completion, waiting time, and turnaround time. Thank you.